Hi, everyone. Thanks for joining today's webinar, a deep dive into Keychain and Spotlight artifacts. My name is Julia Shea, and I'm the Global Marketing Manager here at Black Bag. Before we kick things off, there are a few notes we'd like to review. We are recording this webinar, and we'll share an on-demand version after the webinar is complete. If you have any questions, please submit them in the questions window. We will answer them into the Q&A at the end. Introduce our speakers. So, Dr. Ashley Hernandez. R&D team as the director here at Black Bag for the development of innovations to address our here from the University of New Orleans and regularly presents his research at a number of conferences. Vico is a senior digital forensics researcher here at Black Bag, where he's responsible for R&D supporting all our software offerings. He holds a PhD in digital forensics, has written various open source tools, and delivers presentations across the US and internationally. Ashley is our Director of Product here at Black Bag and has over 15 years of experience in the field and has taught and certified investigators in digital forensics and security topics. Thanks for joining us today, everyone, and welcome Joe, Vico, and Ashley. If you are ready, I will hand it over to you first, Ashley, so we can get started.
Thanks, Julie. We're going to today have Joe and Vico presenting some of the new features that are coming out in our software and presenting them from the technical aspects of how you're going to be working with Spotlight and Keychain and what data that has and what value it is. But first, we did want to do an announcement because we are adapting to some of the changes that are happening. We know that more employees are working from home, and we've really heard from you that you need the ability to collect remotely from Mac systems without having to send the Macquisition hardware. So really quickly, there is an announcement that's going to go out today, but I just wanted to give you guys a quick overview and then we'll dive into it. It'll just take a couple minutes. So I know many of you are Macquisition customers, and for a limited time, we are going to provide you a software license to use for Macquisition so that you can run it live without having to ship the hardware. So this would allow you to collect from any machine that you need to, from remote machines, with the license that's going to be made available to you. So there is a new announcement that's going out. It's being loaded into your accounts today. If you are current on Macquisition SMS, that's going to be a DMG and a software license that you can use. So there is going to be an email that goes out about. I just wanted to know the reason that we're doing this is to really help you kind of bridge the gap right now as folks are trying to work on gathering information from Mac machines. So with this, you'll be able to send that DMG and the license to the remote computer, and you can either give that person instructions on how to run it, or you could remote access into that machine and collect the files with Macquisition. You won't have to use any hardware for that, but you'll be able to send that over to them. Once they collect it, it'll be in a logical evidence file. There's not going to be any internet connection used. This is pretty much an offline solution, so not meant to be long-term, but we are going to be giving you this license to run at least until the end of April, and we'll go ahead and look after that if this is still something that you guys need to be able to use it. So what it's going to look like for those of you, it'll probably be in about an hour. It'll be up if you own Macquisition or purchase Macquisition. You're now going to see in your user portal within the Black Bag website when you've registered your MacQ dongle, the software license. You can download the software. It's listed here as the DMG, and then save the license key. I've blurred out mine, but it'll be available for you to use instead of having to connect the hardware dongle. So when you run that DMG, just like when you're normally in live mode, if it didn't detect the license for some reason or it was expired, you'll now get a choice to enter the license key and you can load it from that file you downloaded from your account. So a couple of notes, and then I'll pass it over to Vico and Joe to talk about the bulk of this webinar, but it is going to be limited to live collection because it is just the software version. We can't do anything about the boot environment right now, so it's just to help you in the near term. The collections will happen on the remote system in live mode. So every caveat we give about running acquisition in live mode still applies. And this version is built off of what we already had. We wanted to get this to you quickly, as we've heard folks needing this functionality. So we may enhance it further at some point. If there's a use case that we haven't covered in this part, then go ahead and let me know if there's something that we need to do about it. So I am going to go ahead now and pass it over to Vico so we can jump into the main presentation.
All right, thanks, Ashley. You changing it over?
I am. There's just a lot more people in the list now. There you go.
There we go. So close. All right, so today I wanted to talk to you guys about some more new, interesting Spotlight stuff. Specifically, most people who are familiar with Spotlight think of file-based metadata for files on the system, but there's a whole lot more fun stuff to dig into, and so I'm going to show you some of it that we're going to have in the upcoming release of Blacklight. So for those who aren't super familiar, Spotlight on Apple systems supports their desktop search, put desktop in quotes because it's for iOS and obviously laptops and potentially other devices too. But anytime you click the little magnifying glass in the upper left and you search for something, you're using Spotlight in the background. Spotlight indexes not just file content, but it also indexes a ton of metadata for files and other things that are not quite files. For our purposes, we're kind of ignore the file content part and focus on metadata. Like I said, it's not just on macOS and OS X, it's on iOS and could potentially be on other systems that I haven't dug into yet, but it's around. It's metadata, but it's not exactly file system metadata. It's not exactly extended attributes, and it's not exactly like EXIF or Microsoft Office embedded metadata. It overlaps with some of those things, but it also has its own set of really interesting stuff that you can use in your investigations. And so just to be aware, the Spotlight, is behind Finder, it's behind search, it links up with FS events. There's a third-party API where your own apps can interface and add metadata to this thing. It's a kind of beast of a subsystem. So there's plenty of little nooks and crannies to poke around in to see some forensics-y goodness. So you'll be able to see the new Spotlight stuff in Blacklight if you go to System up top and then Spotlight over here. And what you'll see on the top window is a bunch of Spotlight records. There's one record basically per file, and a record holds all of the metadata that Spotlight knows about for that file. So here we have something highlighted, and we have some of the metadata in this upper window, some fixed metadata, and then we have a bunch of other freeform kind of metadata that applies specifically to that file down below. So if we blow that up a little bit to get kind of a better idea for basic file-based Spotlight metadata, you see things like content creation and modification times, the type of data, where it came from, file names like airbag.pdf. So I'm calling this basic Spotlight file metadata, but don't think about it as being too basic, because there's all kinds of fun stuff in here, like evidence of airdrop activity and who sent and who received and usernames and when, and author types for documents like we have here, and who printed a document and when. There's all kinds of fun stuff just in the standard file-based things. But there's more. So what about folders? Normally when we think of metadata, we think about files specifically, and maybe not so much for folders outside of maybe file system metadata for like access and creation times. Well, in Spotlight, folders are like first-class entities like files and have their own set of metadata. So in addition to like the name and access times and creation times, for some folders, and not all, Spotlight can keep track of the last time the folder was used, even a notion of the number of times it was used and past dates when it was used. So super interesting information that most people may not think to look for. So keep in mind, though, the number of times it's used is not, it's only an indicator. If you go click and open a file several times, sometimes you'll see it increment, sometimes you won't. Depending on how you open a folder, it may increment 0 times, 1 time, or 2 times. So there's some squishiness in there, but it's a good indicator for things that haven't been used a lot or things that have been used a lot. Also note that the last use date has an actual time associated with it. These use dates down here just tell you a day and not a time. We'll see there's lots more use dates around, and it works that way all the time. A last use date will have the time generally, and the use dates will just have the day. So folders, another good place to look for Spotlight metadata in Spotlight. What about special case folders like .app folders? .app folders are they're basically executables under macOS. And so what does this tell us? This is also a folder, and it also has a set of metadata. But now this use date, use count, and last use date, these things tell us when the program was executed. So you can see the last time the program was executed, a squishy kind of notion of the number of times it's been executed with the use count, and then days when the application was executed. So this is kind of like a user assistant prefetch and stuff on Windows, only you have it for Mac. So in addition to that, Spotlight newer versions of macOS keep track of separate stores under each user's home directory. So if you look at this path under users, library, users, a username, library, metadata, whatever, you'll see these store.db files and .store.db files. That's where most of the meat of all this comes from. And when you look at those and you parse them, they have records just like the stuff that we looked at previously. But sometimes these records don't apply directly to files. They can apply to other kinds of forensic artifacts that aren't just file-based. So this this metadata record is for an individual reminder or to-do item from mail.app. So for this one particular to-do item, we have the item title, Ask Linda about Belleville, which is basically what the reminder was to do, the app that it came from, when it was created, when it was completed, all kinds of fun stuff about this. That again, it's not specifically to a file. Same thing can happen for bookmarks and notes and history items and all kinds of fun stuff. For another example, we have Safari history item. This is a Safari history item. And the idea here is that it's for one individual history item for a Google Maps search with use counts and use dates. So this is for, history items can exist in a plist on the system. And instead of it being these metadata being for the entire plist, it's for an individual item. So you can see that the user visited this page that was actually a Google Maps search, where the user searched for car storage in Vancouver. And you can also see latitude and longitude for results that showed up. You can see exactly when it was happened. This also has a last use date associated with it. It also has a use count and used dates. So you can see if someone went back to this over and over and over again, what you would be able to see. So again, these are just two examples, and there are tons and tons and tons of them. Not only Apple built-in apps, but also third-party apps. So as we said earlier, there's a third-party integration. So any app that's out there can say, hey, I know about some particular type of file, and I'd like my metadata for this particular type of file inserted into the system, and Spotlight will happily take it and display it to the rest of us. So you really never know what you might find. So we've talked kind of about the system level stores that are standard and have data for files and folders, and user level stores. So again, I didn't mention this before, these things that we saw in those previous slides are directly attributable to specific users on the system. So the standard older version of Spotlight stuff stored everything in the root of a volume and didn't have a notion of user access so much, but those user level things point to a particular user. It's only recently that people have been able to parse these iOS stores. So newer iOS devices have their own set of stores. They have multiples of them. There are 3 on all of the iOS devices I've seen at a path that looks like this, private var, mobile, core Spotlight, and then 3 separate directories that have stores. The NS file protection complete, NS complete unless open, and complete until first authentication. these different stores, the data that's in them is accessible when the device is running different ones of these stores based on the actual state of the device, if the user's logged in or if it's been rebooted or those kinds of things. Also note that to get any of this stuff, you do need to have a full file system extraction using Celebrite or Graykey or one of other number of tools. This right here is a metadata item for Maps, the Maps app. So we see the location data that was used for something that was looked up in the Maps app, along with actual address information, times when it was used, just all kinds of fun stuff that you might not think to look for. This is another record from an iOS device. This is from Tweety2, a Twitter app. So this is actually obviously from a non-built-in, a non-Apple app, where a user did a search for March for Our Lives on Twitter. You can see all kinds of Twitter history for pages for other people's profiles that have been visited, other types of searches, all kinds of fun stuff here. Again, with things like creation times. These are a lot of these sets of metadata that I showed you are kind of snippets. There's more to be seen, but tons and tons and tons of metadata with usage times, usage counts, and again, specific to particular users. This stuff on iOS doesn't exist within a user directory, but generally, iPhones have one user anyway. So obviously, this is still, in some sense, attributable to one specific user. But there's more. There's more than just file, subfile, and folder-based metadata. Like I said, there's a lot of moving pieces to this Spotlight stuff, and there's tons and tons and tons of other little corners where there's interesting data. So this I'm going to take a second to talk about. So in the system level Spotlight directory for a volume under .spotlight-v100, that's where the standard Spotlight metadata for files and folders, like not the user stuff and not OS stuff, the standard Spotlight stuff is all stored under there. If you dig down into this directory, eventually you'll find a folder called cache that has some arbitrarily nested integer directory names. At some point at the end is a text file. This text file holds some text from the system. Now note the file on the system can be deleted. So you might have text from a file that was on the system. The file, this particular entry up top that highlights or where the text came from, you can find by using the name of the file. The name of the file, this 1697144, is the inode of the file that was on disk. So inode, catalog node ID, I just say inode all the time, regardless of the file system. I think you get the point. So we can look at the rest of the metadata for this file. So the file that all of this came from was called BMW infotainment.docx, and we can see date added, when it was added to a folder, last used dates, use counts, times, what kind of content it is, all kinds of fun stuff here, just like we saw for other file-based things. But we also have this cache file. Let's take a look at that a little bit closer. So if we go and use the inode number, use this 1697144 and look on the system, we'll see that we can find the BMW infotainment.docx file. And if we look at the file's content in the preview here in Blacklight, you can see this text, buy now, fabulous condition, BMW, yada, yada, yada. So if we go and look for, if we go back to this path and we go look at the .text file that's in this path, we can go grab it and look in the cache folder under some directories and eventually find this 1697144.txt file. And you'll see exactly the same text, buy now, fabulous condition, BMW infotainment system. So really cool that you might find extracted text from files that are no longer on volumes. You might find extracted text that no longer matches the current text in the file, so you can get past history. Before anyone asks me, we're not sure of the exact mechanism of exactly why these text files are created or when. They tend to be there sometimes and not there other times. But when they are, I think you can see how these can be extremely useful. The next thing I want to talk about is Spotlight search history. So we said that anytime you click the magnifying glass and you start typing, you're using the Spotlight backend to search for something. It turns out that Spotlight tracks this stuff as long as you actually select a result. And every time you type in something, if you type in TERM or SAF and Safari shows up and you click on Safari, a new entry shows up in the P list located at this path that contains the text the user typed. So like SAF for Safari, the search result that the user actually clicked on, the full path to where that search result is on disk, and then when the user actually did the searching for the last time. So really interesting information about user activity. In Blacklight, this is going to show up under actionable intel. We'll see a new entry in addition to all the stuff that we added in our last release. There will be a new entry for Apple Spotlight shortcuts. This is what they look like. I'm going to zoom in a little bit, and you can see that for this particular user, Josh, again, note that this path is under a user's home directory, so the search history is directly attributable to a specific user on a system. We can see that the user Josh, for example, typed in F for searching for Firefox and eventually clicked on the displayed Firefox.app. The Firefox.app links directly to is an application in Firefox.app, and this is the exact time when it happened. So this list can get extremely long sometimes. So again, timed usage information for things that a user searched for. So that's most of the new things that I wanted to talk about. It would be great for investigators to know and to keep in mind that they have this super powerful stuff at their disposal. That Spotlight is not just for files. It's more than just Mac OS. It's on iOS as well. It's on old versions it's on OS X and Mac OS. It's still in Catalina. They keep changing things every now and again to make our job on the research end a little harder, but the data stays pretty similar. More than just files. Tons of info on actual usage. So we've seen that all kinds of things, file history items and folders and files can all have last use times, can have lists of use times. They can be attributable to specific users. They have use dates in the past, all kinds of things that let you put together a picture of what a user's been up to. And then I'd like to stress again that while most of what we looked at was for basically Apple built-in applications, Chrome can leave residue around, Evernote I've seen leave residue around, all kinds of other apps can leave residue around, just sitting there in Spotlight. You could certainly use just the Spotlight directories as an interesting kind of triage mechanism if you want to know what a user's been up to on a system and what files are there and the metadata about the files. Also, these third-party apps can add any arbitrary like metadata attribute type that they want. So we looked at use dates and use times and file sizes and whatever. They can literally add something that that says swimming pool size or something. I don't know. It says swimming pools on the brain right now because it's hot. But they can add any kind of metadata attributes that they want. So you really never know what you'll find. There's no fixed superset of all the possible metadata entries that you could find. That's most of what I had for today. Do we have any questions?
We do. We have a couple of questions, and you can add questions for attendees if you want to the question box. So the first question is, how many entries will be displayed for item used dates?
I've seen item used dates for a machine of my own that had hundreds of entries in it. So hundreds can be there. I've never seen more than hundreds, but I've definitely, it was actually in a presentation from like 2 years ago. Hundreds of times that I used Chrome and clicked on my downloads folder. Both of them had hundreds of entries.
All right.
Going back a couple of years, mind you.
All right. If a Spotlight file is recovered on a portable hard drive previously connected to a Mac, would it be encryption? And there's a couple of questions about how the Spotlight files might be encrypted. Could you talk a little bit more about encryption?
Spotlight files are only encrypted if the disk is encrypted. Spotlight itself doesn't, the store files where we pull all of this data from is not encrypted. Now, the data in there most of it is compressed. And in addition to it being compressed, just to make things more fun, it's compressed not just using one compression algorithm. There's multiple different compression algorithms that can be used. So if you go look at the file in a hex editor, it might look like a bunch of mess, but it will not be encrypted. It's encrypted the same way any other file on the disk would be encrypted. There's no encryption on the disk. Spotlight's not encrypted either.
All right, we have some questions since you did mention Chrome. Do you know if incognito mode affects whether those entries are added to Spotlight?
I don't. That'd be a super interesting thing to look at, though. I've got a funny feeling that it won't, but that's purely just a hunch.
A couple of folks noted that the use states had generic times, like more looking like an offset, like 400, 500, those kind of things. Can you speak a little bit more to what we're talking about with those generic times on the use dates?
Yeah, those are just those represent the offset time zone where the person was when the activity, or where the machine was where the activity happened. So if on my personal machine, all of those things generally say like 0600 because I'm in Central Time, GMT -6. So you can actually use that to get an indication of where the device was, what time zone it was in, when that thing occurred. But again, you're basically only getting a date and not really a time.
A few more questions about where things might be recovered from as far as Spotlight. Do you know if we would be able to recover Spotlight files from Time Machine backups?
Boy, I don't know that. That would be good to know. I know that we're not currently processing them in Blacklight, and I'm not sure if they're covered in Time Machine or not. I will admit I'm not a Time Machine expert at all. Don't know that one. I'll definitely get back to you, though, because now I'm curious too.
And then last question, and then we'll move on. And if we didn't get to your questions, because we have quite a few coming in, we will follow up after the webinar on the Spotlight pieces. But do you have any idea when Spotlight metadata collection began to happen, or how long this feature has been around?
Oh, it's been around, I don't remember exactly, maybe 10.5, 10.6 maybe. It's been around for a very long time on OS X. I think I'm not entirely sure about iOS, mostly because I've only had, you have to be able to get a full file system dump, and I've only tested full file system dumps for recent versions of iOS. But Mac OS stuff has been around for a long time.
Great. And just to note, a lot of what you were showing today is definitely the version of Blacklight that's coming out shortly or later this year. So I know there was a couple questions around that. So any other questions before we, well, actually, yeah, I think that's all the questions we'll do on this section, and then we'll go ahead and move over to Joe's section.
Okie dokie. Joe, where are you at?
I'm here, I got it.
Yeah, cool.
All right, welcome. My name is Dr. Joe Sove. I'm the Director of Research and Development at Blackbag. And I will be talking today about some internals of the macOS Keychain, a little bit about how it works under the hood, as well as give you some information about how you can take advantage of those artifacts in our upcoming release of Blacklight 2020 R1. The macOS Keychain is the password management system that's been built into macOS for pretty much forever. It even existed before macOS 10. We talk about this as a password management system, but in fact, it can store arbitrary data. But it is mostly used to store things like passwords or session keys for cloud apps, private keys, certificates, etc. It's a generic secret store where you might want to store things that you don't necessarily want to leave unencrypted on disk. The important thing to note, and we'll give a bunch of examples about this, is that while the secrets themselves are encrypted, there's a large amount of encrypted attributes that you can think of as metadata for each one of these records that are stored that are not encrypted and can be forensically useful. So even if you don't have a password to unlock the keychain itself, parsing a keychain can still be very, very valuable. The keychain database files that we're going to talk about, these are the specific artifacts, or stored in a number of places, right? So there are two classes of keychains. There's a system keychain, and there's usually only like one of these per system, which is going to be stored at the /library/keychains. This is going to be a .keychain file. And this is unlocked, not with any sort of user's credentials, but with a file on disk. So we also need to take into account this file on disk. This is, these two paths may actually represent the exact same file on systems, because on later systems, the var DB system key is actually symlink to private var DB system key. But by reading this file, which is normally protected by the operating system just due to the fact that it's owned by the root user, by reading this file, we can just go ahead and decrypt all the information that's in the system keychain without needing any password whatsoever. The system keychain usually contains information that every user on the system needs, such as Wi-Fi credentials and things like that. For those of you who have used Mac OS, you know that if one user authenticates with a Wi-Fi access point, every other user is also able to authenticate with that access point. And in fact, even when no user is logged in, the computer itself can authenticate with the access point. And the way it's able to do this is because those credentials are stored in the system keychain, which is not unlocked by any particular user's password. So of course, when we're dealing with a disk image, we don't have to worry about any sort of file permissions. We can simply go ahead and parse that file off of the disk image and automatically unlock the system keychain for you. Now, user keychains are a little bit different. User keychains live in the user's home directory, a subfolder of library keychains. They can either be .keychain files or .keychain-db files. It's the exact same format. For whatever reason, they use multiple extensions. And these keys, the data is encrypted off of a key that is derived from the user's password itself. So if you don't know the user's password, we still are able to parse this and get a bunch of information about the attributes. However, the actual payload or the data of the record itself is not able to be decrypted. But if you have the user's password, then you can go ahead and read all of the data. The design of the keychain itself is based off of this old standard Common Security Services Manager, which was an open standard that was proposed for applications to be able to provide cryptographic services to the user. This was how macOS used based off its cryptographic system back in the day, starting with OS X 10.0. However, the use of this was actually deprecated in OS X 10.7. However, the keychain format has not changed. So these legacy formats, and when we get a little bit more into the encryption, you'll see, are still in play when the keychain within the keychain. So things may not be as secure as they would be if this was designed today, but I suppose this is for backwards compatibility. The keychain database still uses all of these structures from CSSM. Apple's keychain implementation is largely open source, but the source code is quite messy and sporadic and spread across a number of projects. But if you're interested in digging into it, it's all available on opensource.apple.com. And if you want more information on CSSM, there's a link there as well. And this will be recorded, so if you need to look back and see that link later, go for it. CSM itself basically sets up, it acts like a database where it allows applications to query records based off certain types. And there are a number of built-in record types, which I have listed here. And the keychain does support all of these record types. The most important here being public key, private key, and symmetric key. But Apple has also extended the CSSM model and added its own custom application-specific types. I've highlighted 3 of them here: the generic password, the internet password, and the Apple Share password, because that's where we focused the majority of our research, and that's where we focused our initial implementation of the tool. This definitely contains the most forensically relevant information. Now, this Apple Share password scheme is not really used that much anymore, but the generic password and the internet password, that's where you're going to find the vast majority of user secrets. Of special note, there's also this metadata application specific type, which we'll talk about in a moment. So while you can query this database by saying, can I have all of the general passwords, you're going to get a number of records returns, and each of these records has a finite set of associated attributes. Now these attributes are optional, so not for every record won't have every one of the possible attributes filled in. But the attributes themselves are actually stored unencrypted in the database. And you can find a lot of really forensically useful information in these attributes. And I'm going to give a demonstration where you can see some of this yourself, but just some examples where you can get the human readable names of these records or descriptions of them, even comment fields, account names, email addresses, service names, so you can see what services the users actually used. Every record also has an unencrypted creation and modified time in it, so you can know when these passwords were added or when they were changed, etc. So even if you don't have any ability to decrypt the keychain file itself, because you might not know the password associated with it, there's a lot of forensically useful information, and we expose all of that to you. So let's talk a little bit about the underlying security and how that affects what we can do for analysis if we don't have a user's password. The data itself is encrypted with the triple DES cipher and what's called CBC mode. While the key itself is 192 bits long, the key is a bit truncated, and just because of how the cipher works and some side effects, you're only really guaranteed 112 bits of security, which is still a lot, I guess, if you had to actually brute force the master key itself. This algorithm is currently still allowed to be used by the NIST recommendations, but it has been deprecated in favor of more modern algorithms like AES, and it has been for some time. Each of the databases has a single metadata record that we mentioned, and if you query for that metadata record, what you're going to get back is what they call a key blob. And inside of this key blob, it's going to contain an encrypted version of two different types of keys. There's an encryption key, data encryption key, or a DEK, and that's used to encrypt all of the data that's stored in the keychain itself, or at least the root key for that. And then there's also a data signing key, which is used to sign the data. That way, after you decrypt it, you can verify the digital signature on it to make sure that the decryption operation happened successfully. These two keys are stored encrypted in the key blob, and they are encrypted by what's called a master key. And that master key is the key that you're either going to want to try to pull from a memory image or read from a file, or that will be derived from a user's password. The system keychain itself, because it's not unlocked by a password, stores the master key in a structure called an unlock blob, which is stored on a protected file on disk. This is that var.db.system key file that we mentioned previously. Now, on normal operations, that file is owned by root, so you would need to have administrative privileges to read it. But of course, in a full disk image, we don't have to worry about that, so we can go ahead and parse and read the contents from that system key. We parse out the bytes of that file, which correspond to the master key, and we can use that to decrypt the keychain file. User keychains work a little bit differently. They don't store the master key on disk anyway. What they do is they use an algorithm to derive the master key from the user's password. Now, passwords can be specified per keychain, and they can change, but usually what it is, the password is usually the same password as the user's account password. Now, they might get out of sync if the user changes their password and the keychain doesn't automatically update. This is especially true if the system is connected to like a Windows domain via LDAP authentication, and then the domain account password changes. And also, if a user manually creates keychain, they can set arbitrary passwords, but usually the login keychain that comes by default is going to have the same password as the user's account password. The algorithm used to derive the master key is the industry standard PBKDF2 SHA-1 algorithm. However, this algorithm, how it works is it has a configurable amount of iterations. And the more iterations you use, the longer it takes to derive the master key from each password. The idea there being that if you use a large amount of iterations, it would take much longer to try to do a brute force attack to decrypt it, because each one of those attempts is going to take longer. Now, NIST currently recommends at least 10,000 iterations, which would take quite a bit to brute force. Apple, since it's using this legacy standpoint, has a hard-coded 1,000 iterations, which means that if you don't know the password, it is feasible to perform a dictionary attack while you're trying multiple passwords, even trying a million passwords or so. And you might, if any of those passwords are valid, you might be able to unlock it within the matter of, many hours, rather than if it was 10,000 iterations, that might take many months or years. So it is feasible to do limited brute force or dictionary attacks against these things in a reasonable time. There's an additional set of keys stored in the symmetric key records called group keys, right? So if you query the record database for symmetric keys, and you look you look for symmetric keys that have label attributes that start with the string SSGP. These are special classes of symmetric keys called group keys. These group keys are actually the keys that are used to encrypt the data of the various password records themselves. Again, just the data. The record attributes remain completely unencrypted. And each group key itself that's stored in the symmetric key record is going to be obfuscated and encrypted with the data encryption key. So if you know the data encryption key, which you can get from decrypting it from the metadata record with the master key, you can use that key to then decrypt these group keys. And then you have the group keys, you can go ahead and decrypt the individual records. Now, of course, our tools do all of this for you, so you don't have to worry about it, but I'm just giving you a little bit of insight on how the encryption actually works. All right, so at this point, I'm going to go ahead and show you how it works. So we'll pray to the demo gods. So this is a pre-release version of Blacklight 2020 R1. And you'll notice a number of changes during the evidence ingestion screen. So I'll go ahead here and try to edit evidence item. And what you'll see is there's this new button here called Manage Passwords. And if you click on that button, you'll see Blacklight now has the ability to store a list of passwords, right? So you can either add these manually by typing them in and clicking Add, or you can click Import and import a text list of passwords where you have one password on each line, and it'll automatically import it. Now, there's a few things to note here if you are importing these passwords, a little bit of gotchas. Each of the passwords are expected to be UTF-8 encoded. So if you're just downloading random password lists off the internet, some of these have mix encoded where they mix like UTF-8 characters and Latin characters. Blacklight will try to let you know if some of the individual passwords could not be imported. However, it is best to just try to make sure yourself that it's UTF-8 encoded. So if you type the password in the GUI like this, Blacklight will handle that for you, but we can't control the encoding of random text files that you may be importing. Another thing to note is that passwords will be attempted in the order in which they're entered. So the passwords you think that might be the most common password you use, you should add those first or put those in the beginning of the file you're importing, because we will stop as soon as we're able to unload the passwords. And if those passwords are at the end and you've got like a million password list, well, you're going to have to wait the whole time until Blacklight gets to that. And don't get a little bit confused, because when you do add them, the password list here will sort them alphabetically just so you can quickly scroll them and find out if a specific password is there, but they will be tried in the order that they're added. So for now, I'm not going to go ahead and process this. I actually went ahead and processed this case already, and I did not choose manage passwords at all. I did not enter any passwords. So we're going to see what this looks like if we don't have any idea what any of the user's passwords would be. So if we go into the actionable intel view, what you'll see here is there's this new a new artifact called Apple Keychain, which is under a new passwords category. And you can see here that we have a number of entries here. We're able to parse through a number of different keychains and automatically pull the information out of them. But you'll notice that the vast majority of these things don't actually have anything listed under the value field, but some of them do. Well, the reason for that being is that the ones that are listed by value, these are majorly your system keychain, which we do not need a user's password to decrypt because we're able to just read them from a file on disk. So if we're able to give you the information, we'll show you here. And this can actually be very, very useful. For example, in this system keychain, you'll see that there are a number of different types of records here. And a lot of them are Wi-Fi records and time capsule backups. And because users tend to reuse their passwords, you'll see that you can actually just use these passwords as a guess and try to re-import the image with these passwords added, and then maybe you'll be able to unlock a number of the user's keychain. In fact, from experience, I know this specific image here, this is actually the password for one of the user accounts, NOVASS. But even for these other accounts that we're not able to get the data, we still parse back a number of very useful information, right? We still have the names of the records, like we can see here. This is a Twitter developer record, and if we scroll, we can see some of these are descriptions, so we know that these are disk image passwords or base station passwords, web form passwords. Some of these have comments built into them. We're still able to get the creation dates and modification dates of the records. The account information. So here is very useful. Here we can see we've got joshbennett_mac.me, Hotmail. So these are email addresses. These are going to be the login credentials for these various services. We can see that a list of the services that this use. So there's a lot of iCloud stuff, obviously. Here's some iPhone backups. We can see that there's encryption keys in here for encrypted disk images, et cetera, et cetera, et cetera. So even without a password, there's still a lot of information here that might be forensically relevant for your case. Now, I'm going to go ahead and open up another case where I've processed the same image, but in this time I insert the password for the user account. And we're going to see here that by doing this, we're able to actually unlock more information. So it works the same way. And what we can see now is a lot more of the accounts now have values. And another thing to note is that even though that this is stored under passwords, remember that the Apple Keychain itself does not just simply store plain text passwords. It can store arbitrary data. So some of this information here is actually just binary data. So if you click on any one of these records, you'll see here in our hex view, we'll go ahead and load that binary data so that you can actually view what the actual bytes stored on. And that's true for anything. For special examples, what you'll find is a lot of the Apple-specific credentials actually store information in binary p-lists. So of course we can go ahead here and we can see binary p-lists, and we can do the strings view on it. But for binary p-lists, we can also click on preview, and we can actually parse. It actually parses out the contents of those p-lists, so you can drill down and see them in an actually human-readable way, much easier than just trying to read a large byte. So I think that's going to be very, very powerful. In addition, some of the fields here you might notice have comment fields, and some of these comment fields and other things can be very long. So if you click on this field, you're going to get the record itself in the hex view, but if you click on any individual cell, its value is actually going to show up in this little preview windows here. So if it's too long to show here in the comment field, you can go ahead and click here and you can view the entire record itself. Of course, sorting works as you would expect, and also filtering. Filtering can actually be very powerful in this view. And this is one of the features of Blacklight in general that I really like, that it allows you to filter on arbitrary fields. But let's say we want to say the description contains, I don't know, a disk password, I think is a applicable one. By doing this, we can see these are all Apple Airport disk passwords. These are the passwords for themselves, and you can see that these are time capsule passwords. We can try to change this to a disk image password. This is going to filter all of these different disk image names, and here's these encrypted disk images that presumably exist somewhere on the disk. And well, there you go. Here's the password that you can use to actually decrypt those disk images. And of course, you can just make this as granular as you want, where you do, passwords itself. Here's all the various different passwords. So Keychain, any third-party application can add arbitrary data into the keychain. So it's really just up to you and your experience to figure out what's in there. It's sort of like the Windows registry or the unified logs and things like that, where there's more information in there that we're aware of. So we just give you the ability to see all of it and drill down. Again, it's not just passwords. So key takeaways, if you're gonna, I know we talked about a lot, but these are the high points that you really should be concerned about, is that there are two different types of keychains, system keychains and user keychains. The system keychains themselves do not require a password to be unlocked. They're unlocked from a file on disk, and they most commonly contain Wi-Fi passwords and other account passwords that maybe need to be used for every system on every user on the system. And users' keychains do require passwords, and if you don't know those passwords, my suggestion would be to check the system keychain first. And by checking the system keychain, maybe you can get a Wi-Fi password that a user has reused as their account password. But even if none of that works and the keychains remain locked, they still contain very forensically useful attributes that we display to you. The underlying encryption that is used both for the passwords and the data is considered marginal by today's standards. So brute force and password guessing attacks are practical, although they may take some time, right? So if you put 1 million passwords in when you're ingesting the process, Blacklight will try all 1 million of those passwords on the various keychains. That might take 12 hours or so, depending on how powerful your computer is. And in future releases, we will take methods to try to increase the speed of that. But mostly the slowdown is due to how the algorithms themselves work, because they're intentionally slow to prevent these sort of brute forcing attacks. But because they only use 1,000 iterations, it is possible. And with the upcoming version of Blacklight 2020 R1, it'll be able to automatically find and display the data from these keychain files in the actionable intel view, whether or not you've inserted the password. That being said, are there any questions?
Yeah, we have several that have come in, and if you guys want to add questions, you can use the question box in the GoToWebinar. So the first question is, are keychains available and are they similar on both iOS and macOS systems?
So iOS does have a notion of a keychain. However, it does not use the same binary format. So this is what we talked about today is only applicable for macOS.
Okay. Next question is, can Blacklight read the secure notes that are stored in keychains? I know you talked about there's more than just passwords there, but the specific question is around secure notes that might have been stored.
The initial release of Blacklight is only parsing those 3 internet keys, passwords, and stuff like that. That's not pulling out. However, the Blacklight's integration with Apollo has a facility to pull down and read some of this information from the secure notes. And Sarah Edwards just put a good blog post about that.
All right, next is, are keychain files stored anywhere on like a recovery partition? I think this is also kind of leading itself to the time machine backups. Is there anywhere else they might get keychain files other than on the disk?
Yes, keychain files can be backed up. They can be copied. They can be moved. Blacklight does not look for these keychain files in any sort of hard-coded location. So if you just import individual keychain files themselves, that will work. The tool just simply tries to find any file with the extension Keychain or Keychain-DB and parses those automatically. So yeah, definitely check your backups, check your snapshots, all of that stuff, because there will be backups of these Keychain files throughout the system.
Next is a question about keychains for cloud sources, so iCloud or other cloud sources. Do we see any of that in Keychain data?
If I understand the question correctly, if your system is using a cloud service like iCloud and automatically syncing with it, what you're usually going to see in the Keychain data itself is not going to be the user's username and password. What you're usually going to see is whatever token is used to authenticate with that cloud service. So you may be able to take that token and bring it into another forensics tool that is able to pull down this data from cloud service. I believe there are a number of vendors, and including Celebrite, that have tools that can do this for you by using these sort of credentials. And as we expand the capabilities of Blacklight, in the future to take advantage of pulling data from these cloud services, we will automatically pull those credentials out of the keychain as well.
All right. And then another question is, when viewing the system keychain and seeing potential user passwords, do we have to reprocess the entire image to try out the user keychain passwords, or can we try brute forcing just the user keychain? Like entering the whole user keychain as a brute force, the system keychain as a brute force.
Yeah. So the current release of Blacklight, it only will try to use passwords that you've entered at evidence ingestion time, which means you do need to take an iterative approach where you process them, pull out those passwords, and then process them again. What I would recommend for that approach to sort of speed it up is what you can do is what you would first bring in the image, put it into the preview mode, which doesn't do anything except for parse the file system itself. And then we have the ability to, and actually we'll just go ahead and demonstrate this rather than just talking about it, which you can find here. What I would suggest doing is selecting a partition, choosing the preview mode, and then only clicking on extract data, which allows you to decide which of these you're going to run, and only run the actionable intel view. And what you're going to see is that this is actually going to process very quickly. Just by that processing, you'll be able to get the keychain, system keychain, and then you can pull those out and then reprocess the image using the keychain itself. Another option would be to go to the file filter and look for all files that have list all files with the name. Well, let's see, the extension contains keychain. And then what you can do is just extract these files, export these files into a folder, and then you can open up a new Blacklight case and just import that folder. And since Blacklight doesn't care about the paths, it will only go ahead and process the keychain files. So that would be the quickest way, just to process the keychain. And when you go in the actual intel view, you'll see that those keychain data will be parsed there. So that's what I would recommend. In future versions of Blacklight, we're going to make this more seamless.
All right, are there any issues with the large list of passwords that might cause lockouts?
Well, there's no lockouts because we're not querying any live system, right? So we're able to query all of this locally from the information that's stored on the disk image itself. So there is no account to lock out because we're not querying a live system. We're not querying any sort of web app. The only thing about having a large amount of passwords is the more passwords that you try, the longer it's going to take the process.
All right, well, I know we are at the end of our hour, so I think those are all of the questions for now.
All right, great.
Great. Yeah, thank you, Joe, Vico, and Ashley for walking us through everything, the new Macquisition Live software license, new Spotlight and Keychain artifacts. And as a reminder, our new live acquisition software license is free to all MacQ customers current on SMS. And if you submitted a question, but we didn't get a chance to answer it, we will reach out and follow up with you individually. So thank you for submitting all those great questions. We are also going to be sending out the recording of this webinar, so stay tuned for that. And if you're interested in learning more about Macquisition, Blacklight, or any of our other products and services, you can email us at sales@blackbagtech.com. And of course, follow us on Twitter, Facebook, YouTube, and LinkedIn, and make sure to subscribe to our blog at blackbagtech.com. Thank you all again for joining, and have a great day.